Okay, hello there and welcome. So we're going to continue on this sort of small algebra course that we're doing. We've previously looked at simplifying algebraic terms. We've looked at expanding brackets, and then we've also looked at factorizing as well. So we're going to look now at what we refer to as double brackets. But before we get into that, we're going to start with the big idea. Okay, so here is a large rectangle. You can see it below, and you can see it's also been split up into smaller rectangles as well. And the question is, what is the area of this rectangle? And I think it's probably worthwhile for you to pause the video at this point and just have a go and think about how you would answer that. So there's actually two sort of main ways you can answer this. So if we remember that the area of a rectangle is going to be the length times the width. Okay, so what you could do is say, well, actually, this is a 4. 3 plus 1 is 4. 4 plus 5 is 9. So this is actually a 4 by 9 rectangle. So we could just do 9 times 4 and conclude that the answer must be 36 centimeters squared. Okay, the other way to do this would be to break it down. So you could work out each of the smaller rectangles, right? So this rectangle here would be a 4 by 3 rectangle. So this would be 12 centimeters squared. This would be a 1 by 4. So that's going to be 4 centimeters squared. Again, here you've got 3 times 5 is 15. Okay, I'll just put that there. 3 times 5 is what we've done. And here we're doing 5 times 1, which again is just 5 centimeters squared. And what's your final thing to do here? Well, it's just to add all these up, right? If you know the area of this one, and you know the area of this one, and this one, and this one, if you were to just add all those numbers up, that would give you your total. So again, 5 plus 15 is 20, 24, 36. And again, we shouldn't really be surprised that the two different methods have given us the same answer. This is just a case of breaking it down and doing it in smaller steps. Now we're going to use this now to think about how we would deal with algebra. Okay, so if this wasn't x, if this was x and y rather than 3 and 4, how we could do this. So let's have a look. What is the area of this large rectangle? So let's just be clear about what's happening here. What we're doing is we need to times a plus 2. So the length at the top here is a plus 2. And we're timesing that by this length here, which is a plus 3. So this is how I'd write this. What we're working out here is this: a plus 2 times a plus 3. That is what we've been asked to work out. And the way we write this is we just write it as a plus 2 brackets a plus 3. And you'll notice that there's this convention in algebra that we don't write a multiplication sign when we're multiplying two terms like this. So before we saw things like, with the single brackets, if I want to do 5 times a plus 1, we were just writing that as 5a plus 1, weren't we? We were just getting, we felt no need to include the multiplication sign. And it's the same here. So this is how I would write this out. This just means this times this. Okay, now I can't actually work this out at the moment, but what I can do is do this step-by-step approach. So this box here would be to do a times a. Yeah, you might remember what a times a is. It's a squared. This box here would be a times 2. Again, you might remember what that is. That's 2a. This box would be a times 3. 3a. And this box would be 3 times 2. And it's nice to see that because we've got an actual integer there. So what was my final step? It was to add up all the boxes. So we've got a squared plus 2a plus 3a plus 6. And so what we're saying then is that this is equal to this. And we can actually go one further and simplify. So you may have noticed that we've got a 2a here and a 3a here. So we could actually simplify this like this. Again, all I've done is I've done 2a plus 3a is 5a. Notice that I can't simplify the a squared. The a squared is a different term. So the answer to my question, a plus 2, a plus 3, is a squared plus 5a plus 6. Okay, let's see another one. Okay, so we've got this question. This is the question we've been asked to answer. 2a plus 3, 3a plus 4. So here's how I'm going to set it out. I'm going to make a big rectangle. This is 2a plus 3. This is 3a plus 4. Okay, I've taken the problem. This is the question that they've asked me to solve. And I'm literally just going to use this idea of a rectangle to demonstrate how to do this. And this is how we're going to think about it. We're thinking about this as a length times a width to find a rectangle. So here we're going to do 3a times 2a. Okay, 3 times 2 is 6, a times a is a squared. We're going to do 3a times 3. We're going to do 4 times 2a. Which is equal to 8a. And here we've got 4 times 3. So again, we're happy that that's 12. And again, we can put our answer now. So our answer is going to be 6a squared add 9a, add 8a, add 12. And again, we can simplify. And this often happens with these sort of questions. We often have like an a term or an x term or whatever letter it is we're using that can be simplified. So here we've got 9a and 8a is simplifying to make 17a. And I notice we've only got one a squared term and only one term that's a number. So these two terms are not going to change now. They're part of our answer. Whereas these because we've got two of them, we can combine them together. Okay. So again, we're going to do this one, and I want you to try and be thinking in your head what is it you want me to do before I actually do it. So do you remember what I'm going to do with this? Okay, would you know what to do now with this? Would you know what goes in here? Okay, 2a times 3a is 6a squared. In this box here. Okay. Okay, and do you know what the final answer would be? Okay, so this is how we would expand this one. And again, notice the steps. First thing I want you to do is set up the rectangle and label it in the correct way. And again, it's as easy as taking one of these brackets, putting it there, and one of these brackets are put in there. That's your first step. Your second step is to fill out all these boxes with the correct multiplication. And your third step is to write it out as an addition and simplify it as required. Okay, so yeah, for this question, when I originally sort of delivered this algebra course, obviously it wasn't a YouTube video, so there was a bit of back and forth. But I want you to sort of play along here. We've got a plus 5, a plus 2. So you can see here we've done the first step of setting everything up. In terms of labeling a plus 2, a and 5 here. The first question is what's behind this star? So what would actually be behind here? And the correct answer is B. It's a squared. A times a is a squared. Okay. These are all common mistakes, by the way. So some students would write 2a here, and what they've done is they've actually done a plus a, but that's not what we're doing. We're meant to be doing a times a. C is another common mistake because a is actually the same as a squared, isn't it? It's just a bad form. It's just not a good way of writing it. You don't write a, you write a squared. Okay, so that's just I'd say that's an example of bad form. It's not technically wrong, but it's just not how we actually go about writing it. And A2 here, again, it's important that it's really clear. So we call this a superscript, or we call it an index. The idea is you need to have the little 2 because it's not really clear what this means. So it must be a small 2. Okay, so again, this is the same question you'll notice. And again, we've filled out some of these. And the question is what's behind the star here? So again, I'll give you a second to have a think. Okay, so I'm hoping that you're telling me that this is 5 times a, which is 5a. Okay? B is wrong because they've put a squared. Well, you don't have an a times an a. All you're doing is a times 5. There's only the one a, so you're not going to have an a squared. This is wrong because they're adding. And this one's fine, but it's just not finished. A times 5 is exactly what you're doing. I don't have a problem with that. But what you would then have to do is write equals 5a, which is which is exactly what we've done here. So it's just that D is not finished. That's just the working out. Okay. And so now what we want is the final answer to this question. Okay. So again, it's the same question. We've done the filling in. Here are our previous answers. The questions given is these. Well, what's the final answer? And again, I'll give you a second to have a think. Okay, so what you should have is a squared plus 5a plus 2a plus 10. We're just adding all the things up. And then we simplify those a terms to get this. So we can see that this is the correct answer, C. B is nearly there, but what they've not done is simplify this. So B is wrong only because it's not finished. It's part of the working out, but it's not actually the completed thing. A is a common mistake, and you might want to have a little think about, what have they done wrong? What's this student done wrong to get A? Well, you might be able to spot what they've done is they've done a squared, add 5a, add 2a. They basically tried to add 1a squared plus 5a plus 2a to get 8a squared. But as we know, that's not allowed because a squared and a are different terms, so we can't combine them together. So our final answer will have an a squared term and an a term. So two separate terms, so you can't combine them. And D is a sort of similar thing where what they've done is they've tried to combine everything. So they've done 1 plus 5 plus 2 plus 10, which is 18, and they've just whacked an A at the end there. And again, it's a common error. It's just some students really, really don't like giving three terms as an answer because you're so used to giving like just one thing as your answer, aren't you? Um, so when you answer something plus something, sometimes students panic and just try and cram it all together. So don't be scared. If you've got three terms for your answer, that's absolutely fine. Do not feel the need to try and squish them together because it's just not something you're able to do. Right. Okay. So yeah, okay. So here's a slightly different question. And again, I just want the final answer to this. I'll sort of leave it up for a second. I suggest you pause it and even just try and just try and work it out. Okay, so I'm hoping that you've had a go at that. You can see we start to fill it in. So I've put the A's in for you. I'm going to put A plus 4 along this side, A plus 3 along this side. You'll notice that I filled the 12 in for you as well, just to help you feel confident there. We know that A times A is A squared. We know that 4 times A is 4A. We know that 3 times A is 3A, and 3 times 4 is 12, which we've been given. So what we'd do is we'd add all these together. We notice that we've got two A terms, which can combine to make 7A. So again, we can see our correct answers here. And there's a couple of incorrect answers. I mean, for example, B is just the working out, isn't it? So B's correct. It's just not the final answer. It's just part of the way to the answer. Again, A is the mistake of trying to cram things together. They've done A squared plus 7A to try and get 8, but again, that's not allowed. And here, what they've done is I'm guessing they've subtracted 4A and 3A. Okay, but an easy enough mistake to make. Right, okay. I think we're going to leave it there. So there'll be some questions for you to have a go at. And yeah, just keep going and keep practicing.